So good evening, everyone. My name is Cheng-Hsin Chuang. I'm from Institute of Medical Science and Technology. So before I go into the introduction of my lab, I should prepare some PowerPoint file for the College of Science, Medicine, because we just established last year, and in the College of Medicine, we have 4 research institutes. And one is our Institute of Medical Science and Technology, and the second one is the Biomedical Science, and the third one is
Professor. Are you open your? Can you open your video? Are you open your video now? Your video is on.
Yeah, my video is on, so you cannot see my video.
I cannot see you talking though. Sakarika, can you guys see?
But I can see.
Yes, Lynn.
Okay.
So
no
we
problem.
have to pin him. You have to.
Okay, sure. Go ahead. No problem. Yes,
okay.
I got it
Okay.
now. Yes,
Sure.
Go ahead.
Okay, so let me just quickly introduce our medicine school. Okay, so because I saw the registration information, a lot of people from pharmacy and bioengineering, biological. So that's why I think maybe we should mention more about a medicine school. So in the medicine school right now, we have 4 institutes. One is the Medical Science and Technology, is where I work for. And the second one is a biomedical science. So, and the third one is biopharmaceutical and biotechnology. And the fourth one is the only one actually in Taiwan is precision medicine. So we have very cool curriculum, and I hope you guys can join our medicine college. Actually, before last year, because our institute already established for 10 years, but before the medicine school established, we actually belong to the College of Science. So that's why Miss Lin, in the beginning, she played a science college video, and in front of the video, there is a COVID spray. Do you remember the COVID spray? The COVID spray actually is developed by my colleague in our institute. Okay, so I'm quite honored to see this video. Okay, so my lab is micro and nano sensing technology lab. So as you can see, actually we doing sensing, we doing sensors by using micro and nano material. Okay, so I have very strange background. So you can see I graduated from civil engineering, but now I in a medicine school. So you might feel very strange. But if you know our lab member, you will see how multidisciplinary in our lab. So, and I used to teach in mechanical engineering for 13 years. So that's why I can cross different discipline. And I also the fellow of International Association of Advanced Materials. So my research interest is patch type physical sensor, biosensor, and smart healthcare. So right now I'm the chair of the Institute of Medical Science and Technology. So as you can see, we collaborate with these 5 largest medical center in southern part of Taiwan. So you can see these are the medical centers. So we develop the sensor, but we will implement the clinical side. So our strategy is scientific research into clinical application. So if you have scientific background, it's okay. If you don't have clinical background, that's okay, because when you come to our lab, you will interact with medical doctor, and you need to go to the hospital to do some research. So the first one is physical sensor. In the physical sensor, we will develop a strength sensor, pressure sensor, and temperature sensor. So because all these measurements are physical, so that's why I said the physical sensor. And the second one is a biomedical material, because we doing some wood dressing and some we call the rapid hemostasis adhesive. So later on, I will introduce a little bit about that. And the third part is biosensors. In our level, we are focused on the point of care by using human urine. So that's why our lab is focused on bladder cancer and chronic kidney disease, these two major diseases in Taiwan. Okay, the final part is we call the smart healthcare. So in the smart healthcare, we try to use some digital therapy, and we also developing some app or using some commercialized chip to do some digital medicine. So the first one is physical sensors. Okay, so you can see this is the nano composite strength sensor, and this strength sensor is very sensitive because we utilize the silver nanowire and the silver nanoflakes mixed with the PU, so that's we can make the PU conductive and is stretchable. So you can see if you can attach to your skin, then we can measure the deformation of your motion. And this one is for the breathing monitoring. So this is the breathe and the exhaust. So we can use this patch type sensor to interconvert to the volume of your breathing. So that's the first published in the world. And another one is pressure sensor. So in our lab, we also try to use some carbon nanotube and mix with the silicone material. So then we can do a flexible and stretchable pressure sensor. And this part is we call the ionic gel strength sensor. So you can see it's fully transparent and very durable and very strong. So they have very good mechanical strength, but also it's fully transparent. It's not like a nano composite you cannot see through. And this one is we use we so-called deep eutectic solvent, but we add some polymer nomener and using the UV curing method. So we can use this material and we can form this into the solid just few seconds. Also, right now we try to use this sensor to monitoring the motion. So in our lab, we not only doing the sensor, we also try to do some motion monitoring for doing exercise for people who will do the rehabilitation at home, and we can know whether he is doing or how he's doing. Okay, so this part is we call the biomaterial. So we still using the deep eutectic solvent to so you can see this is the like a adhesive, and this material is very good antibacterial property and a very good blood cutting testing. So you can see if you use our material, the cutting time will reduce maybe about half. And we also doing some animal test. So you can see this is if we cut the mice tail, and you can see if you use our adhesive, the blood is less and less. And we also doing some surgery with the mouse. So you can see this is the liver. If we use a knife, and you can see the liver will bleeding. And if you use our material, the bleeding will stop very fast. So regarding of the biosensor, in our lab, we are doing electrochemical sensor. So I just make two examples for you. One is for sensing creatinine, another one is for the bladder cancer. So for the chronic disease, one very important indicator factor is creatinine in the urine. But as you might know, creatinine usually, if you try to sensing the creatinine, you need to use the enzyme. But the enzyme cannot be used at home because you need to preserve it in the refrigerator at 4 degrees Celsius. So in our lab, we try to synthesize the copper oxide. So you can see this is the copper oxide, and we also modify the functional group outside the copper oxide with sulfate ion. Then they can have very good specificity, and the most best part is they are not they don't have to use the enzyme, and they still have the electrochemical signal. So you can see after 6 months, and we just preserve this sensor in an ambient environment, the signal is only decreased 1.3%. That means it's very good for use the rapid screen at home. I think all of you after COVID, you already learned how to use rapid screening, right? So we in our lab, we also try to do different kinds of the rapid testing at home. So another one is the bladder cancer, and we use the biomarker is APOA1. So bladder cancer is if you try to detect the APOA1 in the urine, that means this is a protein. But a protein is hard to make the charge transfer. So in our lab, we try to using more conductive material like so you can see we use the silver nanowire and coating the gold nanocrystal outside and mix with the BSA nanocomposite. Is a very complicated nanocomposite. Is porous composite and also conductive composite. Then we can use the antibody to binding with the target biomarker. So we have the electrochemical sensor, and you can see the specific is quite good. So all these proteins you can find in the urine, and they only react with the APOA1. So that means our sensitivity and specificity is quite good. We were developing the app. So you can see this is the app is for migrate app. And we also try to monitoring the physiology signal to detect the pain. And this is what we ongoing project. So you can see we have 2 ongoing projects, all using the patch type sensor. And what kind of student we are looking for? Actually, we have no GPA requirement, and we prefer, as you can see, chemistry, material science, physics, mechanical engineering, biomechanical, mechanical engineering, computer science, other STEM related fields. So in our lab, you will find a lot of research aspect you can fit in. So I hope you just possess the following quality is more passion, and I think the attitude is more important than the capability. So in the future, I think master student can go to a PhD student, and the PhD student can go to a semiconductor company or some bio industry in Taiwan. And if you would like to stay in academia, of course, postdoctor also welcome. So here is my lab member. So I totally about 13 members, and about half and half is master student, another half is PhD student. As you can see, I have 4 India students in our lab. So welcome you to join my lab. Thank you.